All right, welcome back everyone. Today we're putting on our military analyst hats for a deep dive explainer on a really fundamental shift happening right now in modern conflict. We're not just talking about shiny new gadgets or tiny incremental upgrades. We are looking at how artificial intelligence is completely rewriting the rules of tactical tempo and decision speeds. Honestly, if you want to understand where warfare is heading, you really have to understand how blisteringly fast data is moving from the sensor to the shooter.
Okay, let's dive into this. We're going to cover the new tactical tempo, upgraded command and control, frontline autonomy, mastering massive data, and finally, the fully autonomous future.
Starting us off, Section 1, the new tactical tempo and shrinking the OODA loop.
Now, you're likely familiar with the OODA loop: observe, orient, decide, and act. Whoever cycles through that loop faster usually wins, right? Well, what AI is doing is taking militaries from a traditionally reactive posture and forcing them into a highly predictive one, shrinking that loop to speeds we have literally never seen before. Consider this single metric: 1 minute. During the Army's Scarlet Dragon exercises, they deployed the Maven Smart System. Before that AI integration, a digital target pass took roughly 743 minutes. Maven slashed that down to under a single minute. Just think about the strategic implications of that for a second. A small team of just 20 soldiers processed 1,000 targets an hour, a task that historically required a massive intelligence cell of 2,000 people. You aren't just saving time, you're entirely collapsing the enemy's window to react.
And this acceleration applies across the entire chain. When we look at the critical sensor-to-shooter loop, detect, transmit, strike, AI is just stripping out all the friction. In another test, AI sped up the transmission of sensor-to-shooter data by nearly 50% during a massive 7,200-kilometer area scan. That isn't just faster analysis, it's an entirely new operational tempo, where the sheer speed of transmission becomes a primary weapon system itself.
Moving right along to Section 2, command and control upgraded and system-wide integration.
So when tactical tempo increases on the front lines, centralized command and control has to upgrade to keep up. Consider the sheer scale of this number: 1.1 million unique users. That represents the Pentagon's private secure workspace called GenIMIL. They brought leading tools like ChatGPT, Grok, and Gemini into a protected environment and onboarded over 1 million users in just 2 months. And incredibly, they did it with zero downtime. The Army alone used generative AI to update 300,000 personnel descriptions in a single week, saving something like 50,000 hours of human labor. It shows that AI isn't just a niche tool for special ops anymore. It's becoming the foundational infrastructure of military administration.
And this brilliantly illustrates how that scaling power directly impacts kinetic operations. Historically, human intelligence officers could identify roughly 50 complex targets an entire year. By contrast, Israel's reported AI system, Gospel, generates over 100 targets per day. Now, whatever your personal take on the policies surrounding this, strictly as an analyst, the takeaway here is about raw processing capability. It is an exponential leap in how data is synthesized, completely changing the dynamics of command and control.
All right, Section 3, frontline autonomous systems, where AI actually becomes the operator.
When this intelligence leaves the command center and hits the actual mud of the physical battlefield, AI transitions from an assistant to an operator, fundamentally changing resource management. So the crucial point is that in Ukraine, an estimated 80 to 85% of frontline targets were reportedly engaged by UAVs. We are talking about 215,000 strikes in just one summer alone. AI-powered targeting pushed drone strike accuracy from roughly 30 to 50%, all the way up to 80%. This massive scale is completely shifting defense economics. The global loitering munitions market is absolutely exploding, projected to nearly double from $1.3 billion to $2.5 billion, with countries ordering tens of thousands of autonomous munitions. The front line is now undeniably autonomous.
And hey, it's not just small drones we're talking about here. AI is graduating to heavy, multi-million-dollar platforms across all domains. Look at these milestones. The Air Force's Vista X-62A tactical aircraft didn't just fly. In early simulations, AI-controlled F-16s went 5 for 5 in dogfights against human pilots. It also flew for over 17 hours completely under AI control. Out at sea, the unmanned vessel Nomad traveled over 4,400 nautical miles, running in autonomous mode for 98% of the journey. The machine is no longer just holding the map, folks. It is flying the plane and steering the ship.
Now I want to pose a question to you, because this is where the puzzle gets really fascinating. Why would a military analyst focused on tactical warfare care deeply about exoplanets and deep space exploration?
Well, that brings us to Section 4, Mastering Massive Data and the Ultimate Proving Ground.
So why care about space? Because finding a hidden exoplanet millions of light years away is mathematically the exact same problem as finding a concealed threat in a chaotic, noisy war zone. Space is the ultimate proving ground for military pattern recognition. Let's see how this builds. NASA's Aegis software allows Mars rovers to choose promising rock targets and correct their laser focus with 93% accuracy without waiting for Earth's permission. For the military, that's the exact code foundation needed for remote, high-risk combat autonomy where communication lines might be completely jammed. Civilian space research is directly writing the playbook for autonomous military operations.
And the pattern-finding ability here is just off the charts. Examine++ flagged 7,000 planet candidates from massive, noisy test data. Another AI system dug through old Hubble archives and found 1,300 anomalies in just 2.5 days, things human teams had completely missed. But the last point here is the real kicker for modern warfare. Large language models didn't just classify cosmic events with 93% accuracy, they could explain their reasoning. They could tell the operator exactly why they flagged something. Militaries absolutely need that. They don't just want a black box that spits out a target. They need systems that spot the unseeable and then clearly explain their conclusions so human commanders can confidently pull the trigger.
Which leads us to our final part, Section 5, the fully autonomous future, predicting and preserving.
We are moving way past AI that just analyzes data or even operates under supervision. We're entering an era where machines actively predict events and manage critical infrastructure entirely on their own to preserve themselves. Just look at the predictive power we're unlocking. The FIRE-SAT constellation is designed to deliver high-resolution imagery globally every 20 minutes, detecting fires the size of a classroom. After the 2024 Taiwan earthquake, AI mapped 7,000 landslides in just 3 hours. In one remarkable trial, it actually correctly forecasted 14 out of 15 earthquakes. When you can predict global Earth events with this level of eerie, unprecedented speed, your resource management and troop movements operate on a timeline your adversary simply can't match.
But predicting is really only half the story. Preservation is the other. 144,444. That is the number of collision avoidance maneuvers executed by Starlink satellites in orbit over a single 6-month period. And the crucial detail? They did this with almost zero human input. We've reached a scale of operations where human controllers literally cannot react fast enough to keep the system alive. The AI just has to do it.
And that brings us to this final, pretty profound thought from the data. AI is no longer just assisting systems, it's actively keeping them alive. As analysts and learners, this is what we need to take away from this explainer today. We are looking at a near future where the tactical tempo is so blisteringly fast and the data is so massive that our critical military and communication infrastructures will have to manage their own survival. So I'll leave you with this question to ponder. What happens to the very nature of human conflict when the machines fighting it are moving, thinking, and preserving themselves at a speed we can't even perceive? Thanks for joining me for this briefing, and keep your eyes on the data.